Permutations are the ordered arrangements of some or all of the members of a given set. And this word arrangements is important. So let's say we have a set S and the members are the letters A, B, C, and D. And say we want to find out how many possible arrangements there are of these letters. So one possible arrangement would be A, B, C, D, like we see here. Another possibility would be B, A, C, D. So these are distinct, these are different permutations. And then another possibility would be D, C, A, B. So there's plenty different arrangements. But if we want to count them all and find out how many permutations there are, then we go back to the multiplication principle. So for our first letter, we have a choice of 4. So 4 choices, and then we're not replacing the letter. So we don't have 4 choices again, we have 3. And then we have 2 choices, and then 1 for our last letter. And there's a name for this number. It's called 4 factorial. And the notation that's used for it is 4 with an exclamation mark. So 4 factorial equals 4 times 3 times 2 times 1. So we'll look at the general principle behind the last example, but first we'll have a look at one more example and then hopefully it'll clarify what will come after that. So let's say we have a set S and it has 5 elements: S1, S2, S3, S4, and S5. And say we want to find out how many possible arrangements or permutations there are of the members of this set when we're counting them without replacement and we're using all of them up. So for the first choice, we have 5. And then, so that for our first choice, we could have either S1, S2, S3, S4, or S5. So we have 5 choices. Then we're not replacing the one we've chose. So we're not putting it back in the hat, or whatever way you want to visualize it. So we have 5 choices, then 4, then 3, then 2, then 1, which is equal to 5 factorial. And that's similar to the last example. So more generally, let's say we have a set S prime, and that has the members S1, S2, S3, ... which means S4, S5, S6, etc., up to Sn. And we want to know how many possible permutations there are of this set. So if we look at this example, there was 5 members in the set. So for our first choice, we had 5 possibilities, and then we took one out. We were left with 4 members in the set. So we have 4 choices for the following place: 3, 2, 1. So similarly, we have n elements in this set. So we have n choices for our first place. And then we take one out. Then we have n minus 1 choices, n minus 2, on and on, down the way to 2 times 1. And that is equal to n factorial. And that's the general idea. So if we have any set, say we had a set with 7 elements, and we want to find out how many permutations there are of all of the members of the set without replacement, it'd be 7 factorial, 7 times 6 times 5 times 4 times 3 times 2 times 1.